Welcome to lecture series on analytic geometry. Meaning of analytic geometry. Analytic geometry is the study of geometric objects using a rectangular or polar coordinate system. The geometric objects of interest are point, line, polygon, circle, parabola, ellipse, and hyperbola. Analytic geometry is also known as coordinate geometry or Cartesian geometry. Lecture 1A on straight lines. Given 2 points designated P and Q in a rectangular coordinate plane, that is, given this point P and this point Q, several lines can be drawn through these 2 points. This is one of the lines that can be drawn through the 2 points. This is another line. The shortest of all the lines joining the 2 points is called a straight line. This is a straight line joining the 2 points P and Q. Rectangular coordinate plane and distance between 2 points. This is what we call a rectangular coordinate plane or coordinate grid. It consists of a horizontal number line, that is this line, and a vertical number line, which is this line, that intersect at a point O called the origin. This is the point O called the origin. The point O is the starting point. The horizontal line is called the x-axis. That's this line is called the x-axis, while the vertical line is called the y-axis. Locating a point in a rectangular coordinate plane. Given a rectangular coordinate plane, the location of a point P on the plane, that's the location of this point P on this plane, is determined by its distance x unit from the y-axis. That is this distance x from the y-axis, and its distance y unit from the x-axis. That is this distance y unit from the x-axis. The coordinate of the point P is named or specified by the ordered pair xy. That is this pair. The first number x in the ordered pair is called the x-coordinate or abscissa, and the second number y is called the y-coordinate or ordinate. Example 1. Locate the following point on the coordinate plane. The point A with coordinate 5, 3, B with coordinate -3, 4, C with coordinate 0, 5, D with coordinate -2, 0, E with coordinate -4, -5, and F with coordinate 2, -3. Solution. Given the rectangular coordinate plane shown here, the point A is located here. This is the location of the point A. At this point, the x-coordinate is 5 and the y-coordinate is 3. This is the location of the point B. This is the point B. At the point B, the x-coordinate is -3 and the y-coordinate is 4. The point C is here. This is the point C. At the point C, the x-coordinate is 0, while the y coordinate is 5. Here is the location of the point D. The x coordinate of this point is -2, while the y coordinate is 0. The point E is here. The x coordinate of the point E is -4, while the y coordinate is -5. Finally, the point F is here. At this point F, the x coordinate is 2, while the y coordinate is -3. Example number 2. Sketch the quadrilateral with vertices A03, B31, C102, and D610. Solution. Draw a rectangular coordinate plane as shown here. Then locate the point A at this point. This is the point A with coordinate 03. The point B is located here with coordinate 31. This is the point B. The point C is here, and the coordinate of that point C is 102. And finally, the point D is located here. This is the point D, and the coordinate of that point D is 610. Having located the 4 points on the rectangular coordinate plane, we can then connect the point as follows. Join A and B, B and C, C and D, and then D and A to obtain the required quadrilateral ABCD. Example number 3. Again, let us sketch the quadrilateral with the following vertices: P05, Q -34, R -4 -2, and S 3.53. Solution. Draw a rectangular coordinate plane as shown here. Then locate the point P here. The coordinate of this point P is 05. This is the location of the point Q with coordinate -3, 4. R is located at this point. The coordinate of the point R is -4, -2. And finally, this is the location of the point S. At the point S, the x coordinate is 3.5 here, while the y coordinate is 3. Having located the 4 points on the plane, we can then connect them as follows. Join P and Q, Q and R, R and S, and then P and S to obtain the quadrilateral PQRS. Distance between 2 points. The distance D between two given points, the point A with coordinate x1, y1, and the second point B with coordinate x2, y2, is given by D equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Proof. Let us draw the x-axis as shown here. Also draw the y-axis. These two axes intersect at the point O, that is the origin. Let this be the point A and this be the second point B. Then the distance from A to B is this. Let us construct a right angle triangle on the side AB as the hypotenuse. Thus, draw a line through A parallel to the x-axis. Let's draw this line. Also, draw a line through B parallel to the y-axis. Let's draw this line. Clearly, these two lines intersect at this point at right angle. Let us name that point C. Therefore, triangle ABC is a right angle triangle with right angle at the point C. Now, let us drop a perpendicular from A on the x-axis and also drop a perpendicular from B on the y-axis. We recall that the coordinate of the point A is x1, y1. So the x coordinate is x1, while the y coordinate is y1. Also, the coordinate of the point B are x2, y2. So at this point we have x2, while at this point we have y2. Now, the distance from A to C is x2 minus x1. That is, this distance is x2 minus x1, and the distance from B to C is y2 minus y1. That is, this distance is y2 minus y1. Clearly, in triangle ABC, the two sides AC and BC are known as x2 minus x1 and y2 minus y1. Hence, by Pythagoras theorem, we can find the side AB. That is, AB squared is equal to AC squared plus CB squared. That is the Pythagoras theorem. But AB is the distance D. AC is x2 minus x1, while CB is y2 minus y1. So putting them here into this formula, we obtain D squared equal to x2 minus x1 squared plus y2 minus y1 squared. Therefore, taking square root of both sides of this equation, we obtain the distance formula D to be D equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Example number 4. Find the distance between the point A with coordinate 2 minus 3 and B with coordinate minus 3, 2. Solution. Let us take A to be our first point and B to be the second point. That is, we let x1, y1 equal to 2 minus 3 and x2, y2 equals to minus 3, 2. Now, let us recall our distance formula as D equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, putting in the values of x1, x2, y1, y2 here, we obtain D equal to the square root of x2 is minus 3, while x1 is 2. So that will be minus 3 minus 2 squared plus y2 is 2 while y1 is minus 3. So that is 2 minus minus 3 squared. But minus 3 minus 2 is minus 5. So that will give us minus 5 squared plus 2 minus minus 3 is 2 plus 3, which is 5 squared. So the distance D is equal to minus 5 squared plus 5 squared. We know that minus 5 squared is 25 and 5 squared is also 25. This will give us D equal to the square root of 25 plus 25. But 25 plus 25 can be written as 2 times the square root of 25. And this is equal to 5 root 2 unit. Example number 5. If the distance between the point P with coordinate minus 3, 4 and Q with coordinate x minus 1 is the square root of 34, find x. Solution. Let P be our first point and Q be our second point. That is, we let x1 y1 equal to minus 3, 4 and x2 y2 equal to x minus 1. Then, recalling our distance formula, D equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. D is the square root of 34. x2 is x, while x1 is minus 3. y2 is minus 1, and y1 is 4. So putting them into this formula, we obtain square root of 34 is equal to the square root of x minus minus 3 squared plus minus 1 minus 4 squared. X minus minus 3 is x plus 3 squared plus minus 1 minus 4 is minus 5 squared. So this will give us this. You know, when you square both sides of this equation, the square of square root of 34 will be equal to 34, equal to the square root sign here will go out on squaring. So therefore, this will give us x plus 3 squared plus minus 5 squared. Now let us expand this to obtain 34 equal to x squared plus 6x plus 9. Then plus minus 5 squared is 25. 9 plus 25 will give us 34. And when you take 34 to the left hand side, that will become 34 minus 34 equal to x squared plus 6x. And that will give us this. X squared plus 6x equal to 0. Factoring x out here, since x is common, we obtain x into x plus 6 equal to 0. If x times x plus 6 equal to 0, it follows that either x is equal to 0 or x plus 6 is equal to 0. That is, either x is equal to 0 or x is equal to minus 6. Example number 6. Given the point A with coordinate 2, 3 and B with coordinate 0, minus 1. If angle BAC is right angle and the side BC is equal to 5 units, find the coordinate of the point C. Solution. Let the coordinate of the point C be xy. Let this be the point A having coordinate 2, 3, and let this be the point B having coordinate 0, -1. Let us join these 2 points by a straight line. Then the point C can either be located this way or this way, so that angle BAC is equal to 90 degrees. So let this be the location of the point C, or here. Then let us join these 2 points so that angle BAC is 90 degrees, or angle BAC this way is also 90 degrees. Let us join this, that is, this angle is 90 degrees. Join BC so that triangle ABC is a right angle triangle with right angle at the point A. It is given that the distance BC is 5 units. That is x minus 0 squared, that's using the distance formula, plus y minus -1 squared is equal to 5 squared. Expanding this, we obtain x squared plus y squared plus 2y plus 1 is equal to 25. That is, x squared plus y squared plus 2y is equal to 24. That's when you take 1 to the right hand side, that will become 25 minus 1, which gives us this 24. Let us number this as equation 1. Now, let us find the distance AB. Using the distance formula, AB squared is equal to 2 minus 0 squared plus 3 minus -1 squared, which is this. 2 minus 0 is 2, 2 squared is 4. 3 minus -1 is 3 plus 1, which is 4. And 4 squared is 16. So 16 plus 4 will give us 20. So AB squared is equal to 20. Let us also find the side AC squared. AC squared is equal to x minus 2 squared plus y minus 3 squared. Expanding these 2 terms, we have x squared minus 4x plus 4 plus y squared minus 6y plus 9. And this is equal to x squared minus 4x plus y squared minus 6y. 4 plus 9 will give us 13. Now, applying Pythagoras theorem to triangle ABC, we see that AB squared plus AC squared is equal to BC squared. We recall AB squared is 20. So when you put 20 here, then plus the expression for AC squared, and that should be equated to BC squared. That is x squared, that is AC squared, is x squared minus 4x plus y squared minus 6y plus 13. Then plus AB squared, which is 20. 13 plus 20 will give us this 33. Is equal to BC squared. BC squared is 5 squared, which is equal to 25. We can rewrite this equation as x squared minus 4x plus y squared minus 6y equal to, take 33 to the right hand side to obtain 25 minus 33, which is equal to minus 8. And let us number this equation as equation 2. Now, subtracting equation 2 from equation 1, we obtain this. 4x plus 8y equals to 32. We can divide this equation through by the common factor, which is 4, to obtain this. X plus 2y equals to 8. Solving for x, we have x equal to 8 minus 2y. Let us number this as equation 3. Now let us substitute for x from equation 3 into equation 1. That is 8 minus 2y squared, that's x squared, plus y squared plus 2y equals to 24. Expanding this, we obtain 64 minus 32y plus 4y squared, then plus y squared plus 2y equals to 24. 4y squared plus y squared will give us 5y squared, minus 32y plus 2y will give us minus 30y. Then bringing 24 to the left hand side, that will give us 64 minus 24, which is equal to plus 40, and then this is equal to 0. We can reduce this equation to its lowest term by dividing the equation through by the common factor, which is 5. Dividing through by 5, this equation reduces to this: y squared minus 6y plus 8 equal to 0. We can factor the left hand side of this equation as follows: y minus 2 times y minus 4 equal to 0. This implies that either y is equal to 2 or y is equal to 4. Now, if we substitute for y in equation 3, when y is equal to 2, you see that x will be equal to 8 minus 2y. That is 8 minus 2 times 2. That's 8 minus 4. That will give us x equal to 4. And when y is equal to 4, x will be equal to 8 minus 2 times 4. That is 8 minus 8, which is equal to 0. So therefore, the coordinate of the point C, xy, is equal to 4, 2 or 0, 4.